I'm not very good at this, but maybe with a little practice I could tell myself to relax it. Will be better next time I try. And even if I still can't do it yet, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
Wait,
It was only a dream, the waves of evil crashing overhead. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too dark, wake up, my love. Please don't give up on me. It's hard. Wake up.
What is up? What is up, you guys? We are back at it again. Another day in 100 days of Rootkit. We keep chugging along here, learning about databases, then immediately applying it to different applications, seeing the full integration, and now moving on to API systems and seeing how we would go about doing it there. And like we talked about, it's pretty much the same Python code we've exactly wrote, except now we're able just to access it in a completely new way, which makes it even more powerful, more epic, more awesome. But before we get into that, let's go ahead and finish up our intro here, shall we? If you don't know, we are Rootkit, a non-profit organization here in the US of A. Do not go to college. Do not go to any other boot camp. Just get our cert. You're watching right now. 100 days. Watch all of it. We'll cover all the items that are going to be in our roadmap, which is everything we're going to potentially test you on the cert exam. All right? So just watch through. Learn. It's free. It's free. Taking the cert, depending on when you take it, not free. But it's not expensive either. You know, $100,000 for a waste of 4 years of your life and then a piece of paper. Or learn yourself 100% free and potentially coughing up a couple $100. A couple $100,000? A couple $100. You got a big brain, all right? You can do the math there, all right? I don't think you have to spell it out. Same thing goes with all those stupid boot camps. They are just so scummy. Pretty much every single one of them. They are the worst. On top of all this free stuff we're doing, if you go over to our blog section, you'll see week 11 giveaway is up and running. On top of all this free stuff we're doing, we're giving away free merch too. I know, we're a charity that does a lot of free stuff. Who would have thought? I know. I'm sorry, we're playing the game wrong. We really are. We're burning through cash. Where does all this money come from? I'm asking the question myself too, all right? There is no money. We're losing lots of it. But we're spreading the good, and that's all that matters, right? So go ahead and enter. Press the green button here to enter, and then you just show that you're subscribed to our YouTube channel, following on Twitch, etc., just the basic things. Alrighty. Additionally, there is a link in the description, and then if you're on Twitch, it's somewhere in the About Us. If you type in... or if you go to that link, you'll see you can donate. Depending on how much you donate, you can unlock certain rewards like our epic stickers, our super cool collab t-shirt, and our exclusive sweater. Additionally, when you donate, 100% tax deductible. All right, avoid those taxes. All right, avoid those taxes. No one likes paying the government their taxes. They don't do anything with it anyways. All right, so avoid your taxes. And all donations are matched 1-for-1 for the first 10,000 donations. So donate away. It's like you're doubling your money. And we have pillars along the way, like streaming for 24 hours straight. Shaving my head here live on stream. No one wants to see except for my mom. All right. Shaving my beard. Look at this thing. I shave it. I lose my powers. We don't need to get there. All right. Alrighty. Let us get into it today. I guess before we do, are there any questions, comments, or concerns? I am also in the events chat over on the Discord. So you jump in, hop in here, get into the events chat. Hey, you can ask questions. If you're a Patreon or Discord Premium member, you can ask questions, and you don't have to type in the normal chat. You can talk to me live. How epic is that? How epic is that? Drink some of this coffee here. Oh, so delicious. Let's go ahead and pull up our code, shall we? Pull up our code, shall we? I thought we did a git commit before we ended yesterday. Did we not? Because this is all yellow here. Which means we changed something. Yeah, we changed all this. Oh man. That's a oopsie on me. So before we chug forward, let's git commit our dungeon crawler because we forgot to do that yesterday. So let me go and cd into the dungeon crawler, and let's go and git add all and git commit and added SQL integration for scores. All right, you can of course in the label put whatever you want. All right, now we've officially closed that out, so we can move on to our API's code base. All right, we're just going to continue. Whoa, what did I just click there? We're just going to continue on from our API's code base. All right, so the folder that we called APIs, or whatever you end up doing with that, we're going to continue from there. All right, if you're starting from scratch right now, you're not really missing much. All right, pretty much this is the layout that you need. Right, this is the layout you need. So what we can do now that we have a database with super cool epic data in it is we can integrate with our API and have it served to pretty much anyone, regardless of what language they are programming in. All right, which is the super awesome, powerful part, because I can sit here and make a library in Python, but it's only good and only works for people in Python. But if I want to support other languages, then I'm gonna have to sit there and program for other languages and add it's a whole mess. Or I can just make a REST API endpoint and host my API from there. And bam, now I support everyone. So it's super, super, super awesome. So before, we can see here that we had a way to get tweets, all right, and a way to post or create new tweets, all right? Get tweets, post, and create new tweets. And where are these being saved? In a file right now. You know what's really good to replace with the file? Database, all right, database. We'll get to that in a second. Let's go ahead and show first how we can make the database available. And then we'll show how we can modify our tweets. So all we need is to copy these two lines right here, like we went over before, because we just need a function and then where this function is going to be exposed to on a REST API endpoint. So this one we're going to be calling high scores, and we can call this function high scores also. High scores. So in here, all we want to do is connect to the database and then do a query and return our results. Super simple. Luckily, we have that code elsewhere. If we go to Dungeon Crawler, do we want the Dungeon Crawler one? Sure, we can grab the Dungeon Crawler one. And if we go to our main right here, here's the code. Let's go and copy that. And let's go ahead and paste that right here. We're missing some imports, so we're going to need to import our Psycho PG2. I don't think I spelled that right, so let's go and just copy and paste. There we go. And looks like we need our date time, so let's go ahead and import our date time. All right, so we got the date time in here. This is actually, we don't really need the date time. We'll just leave it there for now. This is pretty much the layout of what we need. Only thing that's we need to change here is we're not committing or adding data. We're querying data. We're getting data out. So we're going to be doing a select statement instead. So we can delete all this stuff, and in here we can do our select statement instead. So we want to select everything, so get all the data from the table. What table? From what table? Public, high score, and then dungeon crawler. And again, we can do lowercase because it auto lowercased everything when we sent it up. So we want to select everything from this table. This is valid. This will work right here. This will get us everything from that table. Maybe that's what we want our high scores endpoint to do. So we can just leave it like that. Remember, all of these are going to be two-step processes. So that means the next one, instead of being commit, we're going to need it to be a fetch instead. All right. So we would do something like fetch. Whoops. I think this is on the cursor, not on the connection. So cursor fetch. And then this one we would want to do fetch all because we're just getting everything. So we just want to receive everything. And it's going to give us a list. A list, remember, lists and dictionaries are the two items we can auto feed to the return for our functions here in Flask, and will automatically make it a valid JSON return, right? Which is what we want, all right? Which is what we want. So right here, we can just go ahead and do return. We need to save this off. So we'll save it to, I don't know, data. It's into some variable called data, and then we can return it. And it's just that simple. It's just that simple. Pretty much this is the exact same code we've seen before. Nothing new, nothing crazy, except now it's wrapped inside of the flasks, and we return the data. We return the data. Any questions on this before we run it and check it out? Before we run it and check it out. Alrighty, I don't see any questions, so let us chug along, shall we? So, let's see this in action. Let's bring up our terminal here, and let's go ahead and clear everything, and we're going to need to run Flask, run, or can I do run dev? All right, let's see here. Tac help. Forget the command to do the custom file because we need to tell it to look at main. Let's move up. Options, debug mode, host, port, cert, key. The key file used when specifying cert. We don't need that. Reload. Extra paths. All right, maybe it's going to be help on just Flask itself. There we go. A for app. So let's go ahead and do tag A, and this is going to be our main.py run, and we do want this in debug mode so we can get the hot reloading going on. Hot reloading going on. It would help if I was in the actual correct directory, so let me go ahead and switch over there, and let's rerun this. There we go. So our server has now started on port localhost port 5000. Localhost port 5000. So let's go ahead and go to this link, and here we go. It looks like everything is working. It looks like we had a default route setup that returns some data, which we're seeing right now. So if we want to see our high scores data, we just need to go to /high scores. So let's go ahead and go to /high scores, and look at that. There's our high score data. There is our high score data from our database. So we have 1, which is going to be the ID, Elijah, which is going to be the name, 10 is going to be the score, and this last one's going to be the date. The date. And we can show this on like how it's super cool, because if I open a new terminal here and we cd to dungeon crawlers, all right, and we do python main, you'll see I'm playing the dungeon crawler game right now. I'm playing the dungeon crawler game right now, and our Flash server is live. If we refresh, you'll see that these are the current high scores right now live on the database. So we can have people right now playing the game. So I'm playing the game right now. I'm just going to press enter so I can die. And live, I just died. Let me enter in a name here. Bob. Live, I click on refresh here. Wow, look at that. Live, this API will reflect the current high scores. So people potentially around the world globally could be playing your game or using your application, whatever you're doing, and as they're doing it, you can set up an API to reflect this data from the database live. All right, live. That's weird. Okay. Well, I don't understand how that photo comes up there, but yeah, that is the super cool aspect of it. Now, we just quickly threw all this stuff up. There's some extra things I may want to do to make it a little bit nicer, mostly so not everything here is a list, because lists again are pretty slow to go through and find items. So it'd be better if these were in a dictionary setup where we had a key and a value, because that will be an O of 1 operation. But it works for now. And now anyone around the world that wants to do stuff with our database and the data and the high score information can do it. And again, that's how you can roll into doing stuff like the grand exchange. When we were talking about yesterday for RuneScape, it doesn't matter if you play it or not. The whole point is you can make something like this site where you can see in-game items live, what their current price is, how much they're selling for, what it has looked like over time, whether you should invest or not, etc., etc., etc. This is what you can potentially build up to. All right, this is the major milestone. The major milestone. Once you have a database set up, the API is the first major milestone. After that, it's child's play. It's child's play to then get something to look like this. Because again, this is not what a software engineer or developer would be utilizing their time doing. What do I mean by that? It's the GUI. All right. Sure, if you're front-end dev, you may, but most of your time will be spent with data, the term pretty things in most scenarios. All right. That's going to be for the UX, UI people. Their job is to not know really how to program necessarily, but how to make things look pretty, how to make things like feel nice for the user when they're interacting with it. All right. If you do know some of those, that's super good for you as a developer. All right. Especially if you want to be a front-end dev. All right. You should definitely learn those things, but it's not necessary. As long as you have this up, then it gets passed on to the graphics people. That's easy mode. They make some pretty pictures. And this is just displaying the data where you need it to be displayed. All right. So if this was, for example, high score names, you just show the high score name here. We already collected that information. It's pretty much just formatting. All right. It's easy mode. This is easy mode. This was all the hard stuff. We did all the hard stuff. Now it's just easy mode left over. Any questions on that before we continue on? We'll show how to modify our tweets here so they get posted to a database instead of a text file. And that way we can then go about making APIs for that. And again, pretty much every service, go and ask your questions if you have a question. Pretty much every service out there will have an API. So Twitter has an API, all right, where you can literally do things like get tweets and you can post tweets. Pretty much exactly what we're about to do. And they all get stored on their database. And it's somewhere in here. It's been a while since I've looked. Here we go, for tweets. So their API here for Twitter, so they have version 2 of their API. You can look tweets up, you can manage tweets, which would be things like deleting tweets. So you can see the delete method here. You can read about it up here. Timelines, search for tweets, see how many tweets someone has ever tweeted, see the likes, the retweets, the quotes, etc., etc., etc. There should be one, is it in fundamentals? No, that's going to be for the layout. There should be also something in here for how to, maybe it's in the manage section of the tweets. But there are ways for you to also post tweets and stuff, because that's how a lot of the actually labeled bot accounts go about tweeting. Bot accounts that people think about that are literally not humans but acting like humans will not use this API. Will not use this API at all. All right, because this API is for things that are going to be clearly labeled as bots. All right, actual bot accounts will not use this API. Instead, they will be basically spinning up machines to look like normal people, like the launched web browsers, and then make scripts to move the mouse around and click and tweet, interact with Twitter autonomously. If you're interested in learning how to go about doing some of that stuff, our AI aimbots repo will show you how to go about moving the mouse, getting screenshots, and potentially doing logic on that. All right, so you can use that as some of your foundation for how you would go about making bots. Alrighty, any questions? I don't see any questions here, so I think we will chug along. So we have another use case here where we're writing to a file. All right, if we're writing to a file, then most likely we can do this in a database instead, and it's going to be better overall. All right, it's going to be better overall. So what we want to do here instead is change this to a database. So we're going to need a table, and we're going to have to figure out what the layout of this data is. So it looks like it's all been going to this tweets.txt file. So let's go ahead and check out this. There we go. There's our beautiful tweets, right? Those are our beautiful tweets here. So this is very, very simplistic. So we may want to store additional information like users and timestamps and etc. So we can spend this time to build upon this, all right? And we can include extra information. So let's go ahead and do that. So we want to design a table. So let's think about it a little bit. Now, we're not going to go make a whole user login system, so we're just going to make it so it just auto uses a default user every single time. But we definitely want to be put right here. We definitely want to have a new table for tweets. In that table, we want to store an ID, all right? Because like I told you guys, you should always just make an ID column by default with that serial stuff, all right? Then we want to store the actual tweet. Then we want to store the user ID, all right? We don't have any user IDs, so we're just gonna make one up. And maybe we want to also store the timestamp. And then if you did have things like the like mechanic or etc., maybe if it's been liked or not. Now, in reality, the liking and the retweeting and stuff like that, those are going to be different tables. Why would those be different tables? Well, who liked it? Sure, you can make something like an integer value here that increments every time someone likes it, but you're able to see when you use these services who liked it. When you do something like that, it's anonymous who liked it. Maybe that's what you want. Maybe that's not what you want. So what these companies will do is they'll set up a completely different table, new table for likes. And in this different table, they will make billions and billions of records, potentially every day. All right, of people liking, well, this one would be only for liking, so other ones would be for retweeting, etc. So you would have literally here, again, some type of ID, and then you would have the tweet ID. This lets us refer to this ID here for the tweets table. So what tweet this is correlated with. Then we would want the user ID. This will tell us what user liked this tweet. And then, you know, you can like and you can unlike tweets. So maybe in here, we have a value for like a true or false, so Boolean value on whether they liked it or unliked it. All right, liked it or unliked it. So this could be a +1 or a -1 technically. We're not storing plus or -1 because an integer value is larger, and that's overkill. All right, it's overkill because you're only going to ever like or not like something, or like, I shouldn't say not like, I should say dislike something, all right, or unlike it. Those are the only two states you'll ever have, which are Boolean. So we would want to have this as a Boolean variable. This is literally how services like Twitter, Facebook, Instagram, TikTok, etc., etc., etc. work behind the scenes. They literally just have tables set up like this, which will hook up all this up. Now you'll notice like this likes table is what we call really abstract, or it refers to a lot of other data. It doesn't have a lot of its own original data. What do I mean by that? The tweet ID is referring to another table that has tweets. This one right here. The user ID is referring to another table with for the user and their ID. All right, so most of the information here isn't actually even in the table. The table actually looks overall pretty empty. All right, pretty empty, and that is a-okay, because the only thing we really want here is this one Boolean value. That's the whole point of this. This table overall is more of a glue table per se. And this is very common when you're dealing with SQL databases, all right? Not when you're doing NoSQL. This is just common when you have SQL databases. You'll have lots of tables that are effectively just glue, where they will store data about the relation of other tables, right? And maybe sprinkle on a little bit of extra on top of it. That is a-okay and just fine, just normal. All right. So let us see here. So now if we ever wanted to figure out, so we wouldn't even have this here if we had two tables. If we wanted to ever figure out how many likes someone has, well, that's simple. We index, all right, the database will index based off tweet IDs, and then we can search up a tweet, get all of the records for that tweet, and then ask the database to tell us how many likes there are. And we can also have the database do the logic of, you know, how many trues are there for the likes, how many falses are there for the likes, and then, you know, do the math in order to tell us an exact number of who liked it, right? Exact number of who liked it. So that is 100% doable now when we're doing it in this type of layout. And then we can also obviously show, like with the user information here, every person that did like the tweet. All right, this is again the more proper setup. We're just going to do a very simpler setup just to show the concept right now. So a new table with these items in it. So we should probably have some type of startup script, startup, for creating that table. So let's go ahead and make a file or a folder called startup. We'll make a file in here and we'll call this create tweet table.py. And let's go ahead and steal some code because we're devs, so we steal things. So let's go and steal this code here. I stole it from the high scored table creation, but it does not matter. It does not matter where you steal it from, just steal it from one of the previous files. So once we steal it, then we're going to look through here. We're connecting the database. Right here, we're creating the table. Right here, we're creating the table. So when we create the table, we're no longer creating a high score DC table, we're creating a tweets table. And our tweets is going to have an ID, it's going to have a tweet, it's going to have a user ID. Now this is just very convenient how this worked out because the ID is going to be the serial value. The tweet is going to be a varchar, which because it's, you know, a tweet. The user ID is going to be a integer value. Well, it should technically be an unsigned integer value. If so, this just says int. I'm guessing it's u_int. We can always go ahead and just look it up here. If we click on any table, go to properties, create column, and in here in data type, let's look at u. whoops, u unknown var, doesn't look like there's any unsigned here, so let's do an I. There's just ints. Interesting. Other databases have unsigned storage, so we'll just ignore that right now and just keep it as an int. All right, we're just going to keep this as an int. Timestamp, convenient. We need a timestamp, and that's going to be timestamp. And what are we missing here? Whether they liked it or not. So let's go ahead and copy one of these rows. We need a comma right here because you can see there's commas at the end of each one of these. So let's add a comma here. We got to remove the comma at the last one because this last one didn't have a comma. All right. This one is going to be whether it was liked or not. And this is going to be a Boolean. Now, maybe you're not sure whether it's called bool or Boolean. So again, we can go back to the database, right click, create column, and type in B and kind of look here and see what it's called. They have bool and Boolean. They have bool and Boolean. So maybe it will work with Boolean, maybe it will not. Let's just keep it in C. Let's keep it in C. So this will create our table. This will create our table. But we need to make some additional indexes here. Most likely, what we need to do is make our primary key, which this next line here will make our primary key for our ID variable. But we still need to clean it up a little bit because it's referring to the old high score DC table instead of tweets. So let's go ahead and copy tweets here, go through, alter table public, and we want this to be tweets. Add a new constraint, and we don't want this to be called high score DC. We want it to be called tweets underscore PK. So the tweets primary key. And the primary key is going to be made on the ID value. Seems reasonable to me. Next would be optional if you want to create more indexes. Now, you could maybe create an index off of the user ID. So that way you can quickly look up based off a user what they've tweeted. So let's modify this one to be an index, a new index based off of the user ID, so we can quickly look up based off users and see how many tweets that user has made. So let's go ahead, create index, and this is the name of that index. So we want this to, instead of high score DC, to be tweets, not level, because we're going to, this is going to be for the user ID. So this is going to be the tweets user ID index. That's just the name of this index. And it's going to be on what table? Our tweets table. And this is going to be the column. We don't want it to be on the level column. We want it to be on the user ID column. All right. So again, you can do this all by hand by doing the GUI here and then generate all of the SQL code and put it into this script. That is 100% fine and 100% valid. But again, like always, try to challenge yourself. Try to see how far you can get without looking, without generating stuff. Try and, maybe Boolean works. Maybe it's supposed to be bool. Who knows? Let's just try it. Worst case scenario, we're going to have to delete a table and retry again. The whole point is to learn it, solidify this information. So let's go ahead and move on. This will be pushing our changes, handling everything. All right, sweet. So this looks like it's golden. Next step would be just to run this. So this is going to be in APIs and the startup folder. So we need to CD, this is all messed up, CD into APIs and the startup folder. Then we're going to do a Python create table. And it looks like everything worked. So let's go to our database here and refresh and look. And we have a new table. Excuse me. We have a new table in here called tweets. And if we look at this tweets table. Oh, did we already create a tweets table or before? All right, I guess we already created a tweets table before. So let's go ahead and delete this tweets table for, that was in here. There we go. That tweets table is now gone. And let's rerun this script. It looks like it still worked, which means it should have made it from scratch. So let's go and refresh. There's a tweets table here now. It looks like it has all of our stuff. It looks like Boolean worked, and this is of data type bool. So it looked like it worked for us. It looks like it may have wanted just the wording bool instead of Boolean, but it still conveniently worked for us. So a note to be taken. And here we go. We got an empty table waiting for some delicious, delicious data from us. Any questions on this? This is something that we've seen multiple times already. At least 3 times. I mean, I think 4 times, because we did some stuff beforehand. Then you saw it again with word guessing. Then you saw it again with dungeon crawler. And now you're seeing it again here with our API stuff. Any questions before we chug along? I'm just looking through the chats right now. Alrighty, let us continue. So we've created this beautiful, beautiful table here. Next thing we need to do is maybe add some data to it. We could do the get tweets, we could modify get tweets, but there's not really any data in it. So it won't be very fun for us to make this because we won't really see much. So instead, let's do posting of tweets first, and we can just check the database to see if new things got added and it worked successfully. So we are no longer going to be trying to write to a file. So we can go ahead and pretty much delete all of that logic here. We did put this in a try and accept earlier, which we can keep around because if for some reason we can't connect to the database, the try will fail and it will go to the accept and will handle any issues we potentially have, which is good for us. All right. So we can go ahead and remove this last one right here. Well, actually we can keep that last one there because we wouldn't want to return any data because we're posting new stuff. All right. So again, we just modified this. All we did was copy our code from earlier, paste it in here, and replaced all the writing to a file stuff, right? Or replaced all the writing to the file stuff. Now you'll notice that our code is no longer dry because we have this DB connect here. We have this DB connect here. Things are not looking too good on the dry lane right now. All right, you're right. We're gonna ignore it for right now. All right, so we can just chug along and give away these examples, and then we'll go to some experimentation on how to make this dry, right? Because we'll try and see if that way will work, but I'm fairly confident it's going to be a little more complicated than you think it's going to be, because when we're using the Flask stuff, keeping a persistent session can be not as straightforward initially, right? Not as straightforward initially. So let's just chug along here. Now we're no longer doing fetching. We're now going to be adding data. So this should now be on a con commit. All right. We're going to commit a con right here. And then for our execute statement, we got to change this, right? So we're going to do that's right, an insert statement, So we're going to say insert, all right, insert into where? We're going to insert into the public.tweets table. And what are we going to insert? We're going to insert some values, which ID we can skip. Then we have the tweets value. And then after the tweets value, what do we have? The user ID. If I didn't mention it earlier, these do not need to be in order. These do not need to be in order of how they are in the database. These can be in any order you want them to be. You are just required when you're inserting data to make sure you have the minimum amount. So just to kind of show that off, I'll have user ID here at the front, and then we can have time stamp next. What are we at? Tweet, user ID, timestamp, and liked. And then we'll just do liked here at the beginning. So just to show you guys, this can be in any order you want. This is not at all in the same order as the database in regards to how we added these columns. Because these columns are ID, tweet, user ID, timestamp, and liked. And this is pretty much in like reverse order because it does not matter. So next is going to be values. So we can go and press enter here, get on a new line. Values. Let's put this one on a new line too, so it just looks a little nicer. So this is where we're going to want to do the initial liked value, which everything by default is going to be false, right? It's not going to be liked at all. The user ID, we'll just set that to 11. Again, this is a made up user ID. Timestamp, which we're going to want to do %s. And then tweets is going to be a %s also because we have to enter those values. So in here, we'll do our comma and then an array. And in this array, we need to give it a timestamp, which is going to be using that module dates time. So we can do date time dot date time dot now in order to get that timestamp. And then we need the tweet, which we're getting from the post. Now, to speed up your memory, when someone does a post, to get the data out of the post, we have to use a very special variable that's here at the top called requests. That variable will magically have the data inside of it for the request that was sent. So request, and inside of the request, we want to get the tweet out. All right. How do we know this is how we get the tweet out? Because it's whatever we want it to be. We want it to be this way, so we're saying right now this is how it's supposed to be, right? All right. And this looks just about good. So this should, knock on wood, work. So let's go ahead, and our Flash server should be good. It's in debug mode right now, so it should auto restart whenever we make changes here. If you didn't put it in debug mode, make sure you stop your Flash server and then restart it, right? Stop it and then restart it. So now we can go to our other file here for using the API, right? For using the API, because we haven't introduced how to use anything like Postman, which is very, very useful for stuff like this. So if you want to experiment with APIs more, I highly recommend you go Google Postman and download Postman. All right, very, very useful tool. Very, very useful tool. I'll go ahead and drop in a link for you guys if you want to go mess around with it. Whenever you're doing API stuff, it's going to be way, way nicer if you just use something like Postman instead of whatever mess we got here. So let's look through what we got here. All right, so let's start from the top. Importing requests. This is how we can make our requests in Python. This is the JSON data that we're sending out, which is just a dictionary in Python. Instead of like, we want our dictionary to be tweet. Why tweet? Because we said, thou shalt send us tweet right here. So in a dictionary format, if this is a dictionary, then the key needs to be tweet, and that data will be our tweet. So let's think of a good tweet that we would see on Twitter. You suck ass. There we go. Beautiful Twitter tweet. I just love that place. It's just meant for encouraging and helping people out. All right, so we got a good realistic tweet here we would see on Twitter. So next we need to then post the tweet. So if we go to /post_test, which if we look here, this is the word guessing game. Here we go, post test. So maybe this should be called something like tweet. All right, so /tweet, and when we post to /tweet, we will be tweeting. So instead we'll change this to tweet. It's going to have our data attached to it. All right, and this will then execute, send off, and try to do our tweet. All right. When this goes forward, remember it's a two-way communication when you're using HTTP because it's using those TCP requests under the hood, which means it's a two-way communication. It's established communications, which means we send something forward and HTTP will respond back to us. It will respond back to us. So we're going to shoot this data forward and it will respond back to us a status code. All right. And we talked about all of those status codes that exist. Anything that's in the 200 range means that, hey, things worked out. Everything is good. Everything is good. So if we get a 200, that means everything was good from our API endpoint. And we're just going to print what it returned to us, the JSON information it sent us back, which is going to be this results success. All right, results success. And otherwise, it means something went bad. So we're going to print out the status code of what went bad. And then we're going to try to print out whether it sent us JSON or just normal text and have it show us what the error message was. All right. So let's go in our terminal here and let's run this. All right. So Python using API. I'm in the startup folder, Python using API, and we'll run. Oh, there we go. We got an error. We got an error. It said you messed up. You gave bad input. Gave bad input is a default message we have right here, but you messed up came from the server. We got a 400 error, which means 400, if you didn't memorize all the codes already, the 400 range means the user did something bad. It's the user's fault this failed. AKA, it's this code's fault that it failed. Why did it fail? It said you messed up, so it's not very clear. What we can do is go over here to the server and see this is where this error had occurred, right? It looks like on the server side of things, we are printing an error, the error that occurred, so we can get some more information. So if we switch from our terminals here, from our client script sending the tweet to our server, hopefully we should see some more information. So it says it failed, which is this right here. And then the error was request object is not subscriptable. Interesting. Request object is not subscriptable. So it doesn't really like me using it this way, which is weird. So let's look at our code down here. Why are you doing this to me? Let's see what the issue was. I swear you could just do request. Is it .json? I swear we could just do requests like that. What we can do is just do a print of requests right here on the database side and see maybe some more information about the requests. So let's resend this failing client, message so we can see the requests get printed out. All right. So it looks like the request got printed out here. All right. So that makes sense. Request does have a lot more going on the insides. All right. It's a whole object. And when we try to print it, we don't just see our dictionary get printed out. We see a bunch of information, or this pointer information per se, get printed out about this request object, which means we need to do dot and then something inside of here in order to get the data that we want to get out of it. So what we can go do is refer to any of our previous code, or we can refer to Google's. Now this is probably a great time to point out how useful Git is, because I don't think, I'm going to turn off this server, do Git, Git status, because I don't think, yes, we didn't put APIs inside of a Git repo. So none of this is inside of a Git repo. So we're not doing any Git commits here. This is a big ouchie for us right now. A big boo-boo for us. We kind of messed up on that point. Why? This is one of the useful aspects of Git. Versioning control. And being able to look back in the past and see what we did previously. We had different logic here previously on how to use requests when we were saving it to a text file. We deleted everything and replaced it with our new logic. We have no way to really look back at that information unless we hold down Control-Z and hope that it's still stored, and we can go back and undo, see it, and then fast forward, do Control-Shift-Z to fast forward back to this state. That's a lot of work, and potentially something could go really, really wrong. But if we were using this as a Git repo instead, we could just go back to a previous commit, look at that snapshot, that official save, check out everything, see how it looks at that point in time in history, and then when we're done sightseeing, we can fast forward back to the future. Like nothing changed. Like absolutely nothing changed. So to show off that flow, if we go over to GitHub, and let's just go to the AI aimbot here. Let's say we were working on the AI aimbot repo, and we just made this oopsie right here. What we could do is, in their GUI, now you can do this via the command line also. This is just an easier way initially to go about it. We can click on commits here, because this, I'm gonna go back right here, commits, because this will show us all of our previous commits. Look at that. We can go to a previous commit. So let's say this is the one we want to go to. All the way to the side here. Browse the repo at this point in history. We can click on this button and bam. Now we can see the repo here at this point of history. And you can see here our branch is no longer main. It's now the ID of the commit. And if we open this in a new tab, let's put these side by side, you're going to see that view code, there's, we're not being delusional. There are differences here. This is the older stuff. This is the newer stuff. And you can see here from the date at the top to how many commits came through are completely different, but also the folder structure is different. And some of the files in here are different because this is a snapshot right here of the past. So this is another powerful aspect of Git. All right. We messed up, so we can try to do Control-Z, or we can go try to do some Googling. So let's go do some Googling here. So let's open up a new tab here, and let's say Flask request. And let's go ahead and look at this guy right here. So here we go. This is what we're trying to look for. So we saw some of these like get data and get JSON. So if we look at what these do, this will parse incoming JSON request data and return it. So this might be what we want to go about utilizing. There's also from values, create a new request object based on values provided, etc., etc. So, and then there's get data. Whoops. This reads the buffered incoming data from the client's 1 byte string. So this is going to be most likely for byte data, not JSON data, or I guess anything that's not JSON data. We're dealing with JSON data, so we can just use the .get JSON. All right, and again, we looked it up because this doesn't have any nice literature here for us to read. So if we do this, it should work. All right, it should work. So we should see in our server here, the request that we sent, the tweet that we sent, get printed out. it will still fail because we didn't change any logic here, but we'll be able to see some progress. So if we rerun the client script, it should still fail like normal because all we're doing right now is trying to print this get JSON data. And if we look here, look at that, it's working and we got the data out. So now that we have this dictionary of data, we should be able to do something like tweet, and this should just print out the tweet, right? This should just print out a tweet because again, this function is returning a dictionary. So then we can just treat it like a dictionary and put this right here at the end and get the tweet out. And if we rerun, look at that. It says, whoops, this still messed up because this is the client and the client messed up. But if we look right here, it says, you suck ass. Perfect. So things are working really, really well for us right now. So this is the code that we need. So let's go ahead and copy this code and let's paste it here. Instead of our request tweet, let's just paste this here instead because now we know this will give us our tweet. Let's go ahead and remove this print statement because we don't need it anymore. And if we rerun our client script now, this should work. And it doesn't. Let me rerun it one more time just to do a sanity check because I wasn't looking. It still fails. So let's go back and let's look here. We're getting a completely different error, which is great. It means we're progressing forward. We're moving forward and we have progress happening. So if we look at this progress, it says that tweets, column tweets of relation tweets does not exist. So is the column, I think, is tweet singular, not plural. So let's go and change that here from plural to singular for that column name. Let's rerun this and we got success. And if we look at our database here and refresh, you'll see that our tweet now is in here. Our tweet is now in here in the database. So everything is working like a charm now. That is super awesome and super epic. So, let's go ahead and go on a break. If you guys have any questions, please put them in the chat. Our break is going to be like 3 to 5 minutes. When we come back, I will address any questions. And when we come back from the break, I'll, like I said, address those questions and we'll go over how to do this get tweet section. All right. I'll see you guys in 3 to 5 minutes. Alrighty, we are back. Continue our journey here through APIs, SQLs, integration. Kamal said, can you leave the page up? I'm sorry. I'm sorry, buddy. I failed you on that one. I will leave it up right here for now while we go through the intro. I'll keep all the little intro things off to the side so you can copy along here. I'm gonna go and shrink that so this looks a little bigger. There we go. So if you guys don't know, we are Rootkit, a non-profit organization here in the US of A. Don't go to college. Don't go to any other boot camp. Instead, you're learning right now. Come to us. All right, come to us. Learn all the things. Get certified today so you can go get a job. All right, we're the industry's best for a reason. On top of all this, if you want to win some free merch, if you go over to blog, you can enter our week 11 giveaway, and it's very easy. Just click the green button, show that you're subscribed to our YouTube channel, following on Twitch, etc., and you'll be entered to win some epic merch. On top of that, there's a link in the description of this video, and then if you're on Twitch, somewhere in the About Us down below, where you can donate. We are a charity, so all donations are 100% tax deductible. Depending on how much you donate, you can unlock certain rewards like our epic stickers, our collab t-shirt, and our epic sweater. All donations are matched 1 for 1. All right, so up to the first 10,000. So every time you donate, it's like donating twice as much. And we have pillars along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one no one wants to see is me shaving my beard. We don't need to worry about that one, all right? We don't need to worry about that one. So let us continue our journey. Are you all caught up, Kamal? Any other questions before we chug along here? All right. I don't see any other questions. So let us continue. So quick recap. We made this endpoint called tweet that only works on post requests, right? Post request, which is a type of HTTP request, right? If you are lost on some of this stuff, make sure you go back and watch the days where we covered API. Yup, is my hoodie been sent out yet? Yes, your hoodie. I sent you the tracking code. So it will be to you hopefully by Friday or Saturday. So the what do you call it? Tweets, you can only access it via the post, which is not accessible via a browser because browsers do GET requests by default, right? GET requests by default. All right, when you run this, it's going to run this function here. This function is going to connect to the database. Then it's going to try to add some data to the database utilizing the current time and the tweet they sent. We have this all in a SQL injection safe format. All right. What we're missing here though is we have no logic here to protect against, what is it? Tweets limit you to like 5 characters. We have no logic here to protect against more than 5 characters, right? More than 5 characters. So if you wanted to be more realistic for your tweeting, you might want to add that in. Right now, technically, you can send me the entire encyclopedia and we'll accept it and put it in the database. So that is a potential issue that you may want to go about doing, right? Because remember, users are always out to get you. They'll always do something wrong. So just take note of that. And then if something goes bad, it will return a 400 error. If everything goes good, it will show success. It will show success. USPS. It was through, we send pretty much all of our stuff through USPS. Alrighty. So let us continue here with our getting tweets. All right, getting tweets. Now by default, when you don't mention a method, it will be a get request. It will be a get request. So we're also going to change this to just tweet. Now, this may be kind of confusing to you guys because tweet here and tweet here are the same. I thought they need to be different. They do. To a certain point. These are different because one is going to work at /tweet for post requests only. The other one is going to work for /tweet, but for get requests only. That is different enough. That is different enough. Even though they are the same endpoint, because how you request the data is different, that is enough to distinguish between one displaying and getting tweets, because get requests will get information. So when you do a get request at /tweet, we will get tweets and display them. When you post to /tweet, you are posting information. You are sending it new information to save. All right. It's just different functionality called the same thing. All right. So in here, instead of reading the data from the text file, we want to read it from the database and then return that information. So we can remove that tweet information here where we're reading stuff. We have this data variable that we can reuse. So let's go ahead and just copy and paste our code. All right, copy and paste our code. We need to change this from a commit to our fetch. Whoops, this is going to not on the con. This is going to be on the cur. So we're going to do our fetch all. This is going to need to be saved into that data variable. So that way we can return it here. And now we need to change our SQL statement here so we can delete all this extra stuff here. Delete all this. And now we need to put a SQL statement into here. What is our SQL statement? Well, we've gone over a couple times how you can get everything, right? That's going to be our select everything from what table? Public.tweets, right? Easy enough. That's it. That is all we needed to do here. So if our server is running, which it is, we can go ahead and check this out. Now, since this is a GET request, that means we can go to it via the browser and we can just test it out that way. So if we go to our browser and we type in localhost and then port 5000/tweets, there we go. We can see we get a not found, which is an issue. Not found. We may need to stop the server and restart it. So let me go ahead and do that. That's the wrong one. Let's refresh. And we still, oh, it's tweet, not tweets. My bad. I'm sorry. Let's change that to just tweet, singular. And look at that. We have our information, our results. So that is super awesome. So if we do a GET request on tweet, we'll get the tweets. So we can see the ID of the tweet, what they tweeted, what user tweeted it, so user 11, what time they tweeted it, and whether it was liked or not. Whether it has been liked or not, which it has never been liked. If we go over to our use API, we can go ahead and do another tweet here, like get cancer and die. All right, all just normal tweets on Twitter. So let's go ahead and rerun this. And if we rerun this and refresh, you're going to see now our GET request shows two tweets. All right, you suck ass and get cancer and die. Super awesome, super awesome. We have a realistic Twitter going on here. And it's utilizing our cool API. And now this is universal. Anyone from anywhere can now use this information in their application, which is super awesome and super cool. If we go over to the Twitter API, you can see it looks pretty much exactly the same how we have it right now. So let's go to like tweet lookup, right? And let's go ahead and do, see Postman, talking about earlier. See, they even encourage Postman usage. Wow, how nice. Their site's down. How about this one? Here we go. This is what I wanted. So this is what you'll get when you reach out to this endpoint. You will get all of your tweets like this. They'll have an author ID, which is the user ID we currently have. All right. We don't have everything labeled here, so maybe that's an addition we should do. Created at, we have that also, which is right here, the created time. The ID, we have that also. That's the ID of the tweet, which is right here. Look at that. We're ready to start working at Twitter. All right. Edit history tweets ID. So this is for all the times it's been edited in the past. We don't have that because we don't have edit functionality. And then text. So this is the actual text of the tweet. And if we look here, we have that too. We pretty much have a perfect clone of Twitter. Literally, almost a perfect clone of Twitter. This is literally how these massive platforms you use every day work, function, and operate. It's nothing fancy, nothing crazy, nothing insane, nothing that would take potentially thousands of people to recreate. All right, a lot of these are actually pretty simple to make. You can remake them yourselves. All right, they have thousands of people because they make a lot of moderation and other tools behind the scenes that you can't really view. That, and then a lot of these platforms go very, very stagnant. Musk, who, whether you like him or not, doesn't matter. He is a workhorse. He gets shit done. So you can see people are very happy because he's pretty much laid off like everyone at Twitter, because he realized they were all trash and they weren't doing anything. He needs workhorse people. So they're rehiring now from the ground up workhorse people because nothing was really being done. That's actually a very common thing in a lot of companies. All right, when they start getting big, we've mentioned this before, when they start getting big and big and big, they don't take the time to set up certain things, metrics, to really make sure people dwell. They start getting stagnant. It's normal though. It's not just for developers, it's for every career field. It's very common for people to get stagnant. So we encourage you guys, don't be stagnant. Always be hungry for more. Always be looking for more and more stuff. Making Twitter is easy. Making Twitter scale to size with all its distributed systems stuff is hard. Agree. 100%. Exactly. That was well put. Lost Luke 1. Perfectly put. Yeah, because when you do scale, that's when your team starts getting bigger and bigger, and you need hardware. And again, that's why I was saying a lot of the time for a lot of the tools are not really the front end stuff. It's the back end moderation, analytics, etc. tools that you don't really see every day, because to keep things up and live, there has to be ways for people to know when something's going wrong. And so there's lots of time that's spent on tools to basically monitor these things. All right. For every little bit of, I'm trying to put a number on it. I don't know, maybe like every new item, there's probably like twice as much backend stuff that needs to be added. But again, you'll see that more and more as you enter your dev career. It's not an excuse, because again, stagnation is a massive thing that happens a lot in a lot of companies. And that's why you always see these startups, and startups will always be popping up and happening, because it's a natural thing for things to get popular and then age out for something new. All right. That's how at least the US economy works. There's not very many 100+ year companies for a reason, because stagnation, they don't stay up with the times. Someone will overtake them. Twitter will not last forever. Google will not last forever. Apple will not last forever. These companies do have an expiration date. All right. It may not seem like they do. They may seem like they are forever, but they're not. Nothing is forever. All right. So the only difference here that we may want to do is maybe set up the rest of our formatting real quick, just so we get a cleaner little output here. Because you can see, it says author ID created at, these are our one-for-one lookups. Right now we have it all in an array state, which is not preferred. It works just fine. It works 100% just fine, but it's not preferred because, again, it's a potential O of N operation, and it'd be easier if we can just look things up directly. So we can modify our backend code here. We can modify our backend code here to allow for this. So let's go ahead to our getting tweets. Now, you've noticed so far that when we get tweet data, we're always being given a tuple or a list back. That's usually a tuple. I think this is a list of tuples when we do fetch all. And like, it doesn't really have any context information. It doesn't tell us what column it came from or any of that information, which is very inconvenient. All right. It's very, very inconvenient. By default, this is how data kind of gets returned, and it's on you to kind of format it in the way you require it to be formatted. There are sometimes ways to get the column information out, right? Get the column information out. So we can go doing some Googling here to figure it out. What I mean by this is that, where's our API right here. We know these first items are always going to be the ID. The second one is going to be the tweet, or not the tweet. This is for high scores. Go to tweet. The first one's going to be ID. The second one's going to be the tweet. The next one's going to be the user ID. Then we have the, what do you call it? The timestamp, and then liked or not, right? Liked or not. Now, we could set up this dictionary looking format, like we can see right here with results on every one of these pretty much manually by recreating this using a for loop. So if we go right here, let's go right here, and let's just do a for item in data. We could say that in our new data here equals result and then an array, and then in here we want temp equals, and then we would manually put here ID, and then our ID is going to be of item 0 because it's in the 0th place. Then another one here would be tweet, or what did Twitter call it? Twitter called it text, so we could say the same thing, item, and this is going to be 1 because this is the second item we get back. Then the third item we get back is going to be our user ID. So I think Twitter called it author ID. So again, you could just call it user ID, but we're just trying to clone Twitter as much right here as possible. So next we're going to do our timestamp, which I think they called created at. And that's going to be item number 3 here. And then the last one is whether it was liked or not. So we'll just do liked. And then item number 4. So if we look here, we need to add this temp to our results. So new data results dot append, and then temp. And then we want to return this new data. So what we did right here is we're manually, this is a way you can go about it. This is a way. There's lots of ways to go about it. This is not the most ideal, but it works. It works. All right. So what we're doing here is when we get that raw information from the database, when we get this raw information from our fetch all here from the database, this is just going to be a generic list of information like this. A generic list of information that just has a bunch of stuff listed out in a list, and you need to know what is what. All right, you need to know what is what in that list. Instead, what we're doing is it's still technically the same list, but we're formatting it a little bit. We're making it all into a dictionary here in Python, which in return will translate really nicely to our JSON data. We're going to basically be labeling what each one of those items are by making a new, our new data variable, which is going to be just a dictionary with results. And inside there, it's going to be a list. Then we're going to go through all the data we got back from the database, and we're going to pamper it a little bit. All right, we're going to clean it up, make it look nice for its debut here. And we're just putting some light makeup on it, essentially. We have a temp variable, which just temporarily exists, gets replaced every single time. And inside this temp variable, we have the same data from the list 0 through 4, right, indexed, except now we're just labeling it using our dictionary, right? We're labeling it so it's all nice and labeled here, and then we're adding it to our result list right here. So that way, when we return it, it now looks nicer. So to have a before and after, I'm going to go ahead and open these both up on different tabs. So this is how it looked before we pampered it. This is how it looks after we pampered it. So you can see it's, let me go and zoom in on these. It's the same data that it's always been, it just looks a little nicer, and we know exactly what each item is. We can immediately say, hey, I want the author ID, give me the author ID. We can just say author ID and get the author ID out of it. All right, there's no like guessing or having to know like, oh, the author IDs are always supposed to be the third item. All right, it doesn't matter if it's the third item or not. If we want the author ID now, we can just ask for the author ID. So this is really, really nice and really, really convenient. And this is ideally how you want to send your data forward. All right, and you can see now it's even matching closer to how, this is kind of annoying. I want it to come up higher. But this is matching even closer now to how Twitter literally has their API lookup for when you want to get tweets. All right. This is the foundation of when you make APIs and you want to share information, and you want to make it as accessible to as many people as possible without having to worry about the language that's being used. Are there any questions on this at all? Are there any questions on this at all? What I was going to say earlier is what would be more ideal is if you could get the column information out of the cursor so you can insert it inside of the data. That would be more ideal. I believe it doesn't work when you do the asterisks. You would actually have to manually type out every column's name here, and then it will match them up properly. Right, then it will match them up properly. If my memory serves me correct, this is also something you could go about Googling, right? You could go about Googling. How you doing, Kamal? Got any questions? So if there are no questions, so tomorrow we're going to take a new step. We're going to take a new step. We're going to put Python on rest for a little bit because I want to finish up our full stack example. All right. So far, everything we've gone about programming wise for the last, we started programming in around day 40 something. So we've been programming for 30 something days, right? Maybe 30 days exactly. I don't know. We've pretty much been in software development / backend realm only. So what do I mean by that? Everything that we've made so far would be something that either you could sell as a product that someone would start on their computer, or would be a backend service for a big service like Google or Twitter, etc. And then the final backend part would be, standing up an API, which depending on how some people would classify it, maybe even middleware territory. But we've been pretty much backend, right? Backend. There are millions, it feels like, of videos on YouTube. Everyone and their dog on YouTube in the developer space is making videos on how to do front end stuff. So we're not going to spend too much time on front end, right? You can look up plenty of videos of plenty of people doing a better explanation of how to be a front end dev than I'm going to be able to give you. Again, front end is not what we're going for right now because this is your comp sci cert. All right, so we're talking about everything, a little bit of everything. So we're going to just touch a little bit on HTML and on CSS tomorrow, right? Then we're going to follow it up with JavaScript and show how we can complete our application and be full stack devs. Full stack is doing the back end and then making the pretty graphics for the front end, all right? So we haven't done any GUI stuff at all. This is going to be our first time getting into GUI stuff. That's what makes it a full stack, a full sandwich, all right? We have the whole shebang. the back of it, the front of it, and all the middle goodness. All right. So we're going to finish that up hopefully this week. Maybe it will drag on to Monday. And then we're going to move back to Python and start talking about multi-threading and multi-processing and how to add that to your application. Trying to follow along. Gonna rewatch after the live stream. Sounds good. Yeah, remember you guys, all this is recorded and it's on the channel. So make sure you rewatch anything that you need and ask any questions after the fact on the Discord in the 100 Days of Rootkit chat, right? Any other questions that you guys have before we end today's stream? So tomorrow will be a pretty easy day. HTML and CSS are not like any of the other languages we talked about. It's very forgiving, and we're not going to get too in-depth in it, all right? Alrighty. I'm gonna wait another 30 seconds or so for any other questions that you guys may want to ask for them to roll in here. But if not, you guys are free to go, and we'll continue our journey tomorrow talking about HTML and CSS, and maybe we'll hit Java, just the intro of JavaScript at the end. I don't know. We'll see. We'll see. All right. I don't see anything else rolling in. So that's all I got for you guys today. So I'll see you guys tomorrow on the next one.